Okay, Assalamualaikum and very good morning to everyone. Okay, tak kira lah pagi ke petang Alright, so kita continue dengan chapter seterusnya. Okay, chapter keempat. Okay, iaitu data encoding. Okay, topik data encoding ni adalah topik rentetan daripada data signal. Okay, yang sebelum ni Sebelum ni anda mengenal signal jenis-jenis signal yang ada di dalam dalam kabel antaranya ialah analog signal dan juga digital signal. So saya harap anda boleh memahami perbezaan antara analog signal dan juga digital signal. Okay, so di dalam topik ini, in this topic basically, you will understand, based on your understand of type of the signal. Now kita akan tengok, macam mana, how your data or your information tu will travel, will transmitted, dalam bentuk signal. So all your data, all your information will be encoded. So that's why dia kata encoded tu, dia akan ditukarkan. The change, the encodes, dia tak panggil change. Change tu bahasa biasa. Dalam bila kita cakap dengan data communication networking, the vocab that you need to use is data encoding. It means that your data has been changed, into a signal. So bila dia changing into a signal sebelum dia transmitted, you kena tahu how this data and how this information has been encoded. Encoded ni ditukar, ditukar kepada signal. Pertukaran proses data daripada bits atau daripada binary awak change into a signal, dia panggil sebagai encoding. So of course dia kena ada encoder lah. Setiap devices that work in the physical layer, they have a capability in change, your data, your binary into a signal before it can be transmitted across the communication medium. Sebelum dia masuk ke dalam medium, tak kisahlah you pakai physical ke ataupun you pakai wireless. So in the more precise words, we may say that the waveform pattern of the voltage or the current used to represent the analog or digital data using transmission. So kita kena represent. Macam mana data awak, pattern of the data awak, of the voltage, dalam current use, yang currently dipakai untuk bagaimana analog or digital transmission. So bila data you dah ditukarkan kepada bentuk signal, maka data tu akan ready masuk ke dalam medium. Tak kisahlah sama ada you pakai wired ataupun you pakai wireless. So some of them are using wired, some of them using wireless, and both sometimes they're using a digital to analog ataupun analog to digital. So dia bergantung kepada cara bagaimana ianya di-access. Alright. Okay, so this is the learning outcomes. At the end of this topic, you should be able to understand digital to digital transmission technique. Bagaimana bila you change to your digital to digital technique tu, ada beberapa techniques. Understand the digital to analog transmission technique and how you apply these signals, that being encoded either digital to digital or digital to analog. So as introductions, all your information must be encoded into the electromagnetic signal. Why? Because your medium, you have a different types of medium. You have a various types of medium for you to, in order to transport, to transmit you punya data or information across over the network. So across the transmission medium. So dia akan lalu, sama ada wired, dia pakai wireless ataupun dia pakai satellite sekalipun. So you kena tahu data you has been changed into the process. Untuk pengetahuan anda, dia sebenarnya ada 4 encoding process. You have a digital to digital, you have a digital to analog, and you have analog to digital and analog to analog. So basically yang dekat di bawah ni dia adalah teknik-teknik how the encoding process is being performed. Alright, for digital to digital, you have NRZ, you have NRZI, and you have a Manchester technique. You have a digital to analog, you have a amplitude shift keying, frequency shift keying, and the phase shift keying. And analog to digital, we have a PEM and a PCM, okay, pulse analog modulations and the pulse code modulation, okay. And for the analog to analog, this is a AM, FM, and PM. Okay, so for your syllabus, okay, they only cater these two encoding process, which is digital to digital and digital to analog. Why these two not being will be taught in this semester? Because these two, okay, still using, they're still using, but we are going to the forward of digital transmissions. Okay, semua data semua dah tukar kepada transmission. Even kita tengok TV commercial kita, contoh TV3, TV1, TV2. Okay, mereka dah tukar kepada digital punya devices. Walaupun dia punya channel medium dia adalah menggunakan analog, tetapi mereka menggunakan dia punya decoder kan, encoder dan decoder dia untuk tukar daripada semua dah tukar kepada digital devices. Digital, even broadcasting also dah tukar kepada digital. So that's why kalau kamu tengok kat rumah semua dah MCMC dia orang dah tukar. MCMC ni dah bagi tahu Suruhanjaya Komunikasi Malaysia, okay, SKMM dah baran semua bertukar kepada daripada analog kepada digital. Jadi maka kamu nampak, okay, berapa banyak perubahan berlaku, di mana kalau kita tengok kat rumah dah tak pakai dah area biasa. So kita masih pakai area juga, tapi kita ada decoder, okay, yang tukar daripada digital kepada analog, analog kepada digital lah. Okay, so jangan risau, benda ni kamu kena faham, okay, bagaimana data, how your data is being look like, okay, before it's being transmitted into the transmission medium, okay, dia kena encoding. So macam mana encoding process, okay. So in this syllabus you only cater for digital to digital and also digital to analog. So you learn only these 6 method lah. Okay, tak susah pun, okay, if you understand the previous the basic, okay, of the analog and digital signal. Okay, sebelum kita pergi lebih jauh lagi ke macam mana digital to digital and digital to analog punya transmission and encoding process dia, so kita kena kenal, okay, kena pasti antara signal element dan juga data element. Okay, okay, so signal element, okay, so signal element, okay, kalau kan kita tengok signal element is the shortest unit ataupun the smallest unit of signal, of digital signal, okay, of digital that is a constant, okay, and the data element actually is the smallest entity that can be present in the piece of the information which is in the bit. Okay, ada beza antara data element dan juga signal element. Okay, data element adalah small piece of information that being exchanged into the bits. Okay, it's a represent piece of information dalam bentuk bit, and signal element adalah the smallest unit of signal that is being constant. Okay, so ada beza antara data rate dan juga signal rate. Okay, data rate, okay, that's why data rate adalah sama dengan the bit rate, number of the bit that can be sent, okay, in 1 second. That is the bit rate. Alright, kalau signal rate is the same as the baud rate. So baud rate is actually the masa yang dia ambil, okay, untuk dia hantar for the 1 bit. Okay, so the bit rate dan baud rate ni akan digunakan dalam all the data encoding process, sama ada digital to digital ataupun digital to analog. So you have to make sure you boleh kenal pasti antara data rate dan juga signal rate. So data rate kita panggil dia sebagai bit rate. So bila kita talk about the data rate, so the data rate must be unit in the bit per seconds, okay, megabit per seconds, kilobit per seconds, gigabit per seconds. Okay, alright, so that is how the bit rate. Okay, kalau signal rate is the same as the baud rate, so signal rate is more with the time, okay, how many seconds of the bit can be sent, okay, how many seconds dari masa, baud rate lebih kepada masa. Okay, kita tengok, okay, perbezaan di dalam gambar rajah ni menceritakan bagaimana perbezaan. Okay, kita dalam it depends pada devices. Okay, some devices dia have one data element per one signal, satu data satu signal. Okay, senang saya cakap. Contohnya one bit, okay, so dia adalah dia mungkin positif ataupun dia negatif lah. Okay, biasanya kosong ni represent as a positive. And 1 will be represent as negative. Alright, so satu bit, satu signal. Okay, this is we call one data element per one signal. Okay, ada juga some of the devices, okay, they use two signals in one element. Okay, so maksudnya dalam satu, they have one data signal tapi dia menggunakan two signal. Okay, so satu data, satu bit, okay, dia mewakili dua signal. Ada positif or whether is negatif. Dia tak boleh kosong. Kerana kalau tu dia kosong, maknanya dia tak ada signal. Okay, alright. So dia sama ada dia positif ataupun dia negatif. Okay, so one data element, one bit of data element can represent two signals. Okay, which is 1 R is equal to half. Okay, alright. Or it can be in two data elements represent one signal. So ada juga, okay, some other devices that convert your bits to the signal tu, dua data element menjadi satu signal. Okay, so ada juga yang buat empat data elements, okay, empat data elemen untuk mewakili tiga signal elemen. So dia ada positif, dia ada negatif, dia ada zero. Okay, so this is how it can the beza antara signal elemen dengan data elemen. So maknanya dalam satu data elemen dia boleh beberapa signal elemen, okay, beberapa signal elemen. Maksudnya ataupun dalam beberapa bit data elemen dia boleh mewakili beberapa signal elemen. So ada perbezaan. So dia bergantung kepada devices, okay, how your devices can be have a capability in change your bits to a signal, whether in the one signal, one data element to one signal, or one data element for two signal, or two data elements to one signal, or four data elements to the three signals. So it depends on the devices, okay, the capability of the devices in converting or in encode your bits to the signal, okay, for either in the signal element and also data element. So it depends. Okay. Alright. So now we proceed with the digital to digital transmission. So before we go to digital to digital to digital transmission, you have to know about the line coding. Okay. So we don't have the line coding. The process of converting your binary data, they have used the sequence of bits to a digital signal. So dia ketukar. Okay, dia akan tukar daripada your bits tadi, okay, your physical layer, okay, daripada dia akan tukar kepada bits to the binary, and this binary we have a line coding. So this line coding will transform, okay, your bits into the sequence of your bits into a digital signal. So you punya bits tu tak kisahlah dalam bentuk teks, data, numbers, image, video, semua akan ditukarkan kepada in the sequence of the bits. So in the sequence of the bits here, line coding will change it from the bits to the digital signal. Okay. Right, so this is have a signal level and the data level. So numbers of values, okay, numbers of values allowed in a particular signal we call as signal levels. So signal levels is berapa banyak the numbers of values that kita allow untuk particular signal tersebut. Okay, values berapa banyak, okay, yang kita boleh hantar, okay, dalam signal tersebut. And the data level is how many numbers of values that you present the data for the data levels. Then we call ada beza lah data level dengan signal level. Signal levels berapa banyak values yang they present for the particular signal, and kalau data melibatkan how the values, the numbers of values that used to represent your data. Okay, so ada beza. So nampak perbezaan Okay, so this is we call as two signals with the two data levels. Okay, okay, two signals, okay, with the two data level. Okay, so 1 is positive, 0 is negative. Okay, alright. So ada juga the three signal level with the three data level. Okay, so positive, 0 and negative. So this is we call a three signal level with the three data level. Okay, alright. Nanti kita akan tunjuk example of it. Okay, so this is example of line coding of digital signals. Okay, they have two of digital signals. Okay, one is the digital signals, okay, with the DC component. Okay, DC ni bukan disconnect. DC is the direct current component. Okay, so direct current components, okay, means that your punya signal, digital signal akan sama ada 1 or 0, positive or 0. Okay, kalau with the direct current. Okay, kalau without the direct current, so your punya signal will be have positive and negative values. Okay, so they ada positive and they have a negative values to represent the bits. Okay, ada beza. Okay, with the direct current or without the direct current. Kalau with the direct current, you have 1 and 0, positive dan juga 0 signal and digital signal. Kalau you signal without the direct current, you have two. Okay, positive and also a negative signal. Okay, dia takkan ada kosong. Okay, so sentiasa ada lah. Okay, alright. So contoh direct current ni macam contoh kalau you pasang plug devices. Okay, ini melibatkan voltan. So kalau kamu direct current, maksudnya kamu ambil plug direct cucuk kepada current tu. So maksudnya you with the direct current. Okay, kalau you without the direct current, so maksudnya you pakai extension ke, you pakai another booster ke. Okay, so then that signal without the direct current component. Okay, alright. Okay, so kita continue our lecture, okay, for the line coding. So, kita akan tengok pass rate versus the bit rate. Okay, this is the formula previously. So, the pass rate defines the number of pass per second. Berapa banyak dalam satu saat, berapa banyak pass dia boleh dia boleh guna untuk translate the data tadi. And the pass is the minimum amount of time that required to transmit the symbol. So, pass ni sebenarnya setiap berapa saat, okay, berapa masa yang dia ambil untuk dia transmit, okay, the symbols, okay, ataupun the data, okay, yang dia hantar. And the bit rate, berapa banyak bits yang dia boleh hantar dalam satu saat. Okay, so pass rate, okay, so the pass rate, okay, the bit rate actually equals to the pass rate times the log to L. L is a signal level, okay, berapa banyak dalam satu signal, signal level yang digunakan, okay, untuk di convert the bits, okay, and then also the pass rate, masa yang dia ambil untuk dia hantar to transmit the symbols. Okay, kita tengok contoh. Okay, dalam case ini you have two signals. Okay, you have two signals. Okay, you have two data signal here. Okay, with the pass rate durations of 1 milliseconds. Okay, maksudnya dia dalam masa 1 milliseconds, okay, dia boleh hantar two data levels. So, first thing kita calculate the pass rate. So, the pass rate is 1 over the pass rate. Okay, masa, okay, yang dia ambil. Okay, so 1 over 10 millisecond is actually 10 the power of negative 3, okay, pulses. Okay, alright, sebab dia nak tukar kepada second. So, you make sure you know how to convert the units. Okay, millisecond ke seconds. Okay, so you kena bahagilah. Okay, okay, so sama dengan 1000 pulses per second. So dalam satu saat, okay, dia ada 1000 pulses, okay, that involve, okay, in the pass rate. Okay, alright. So kenapa 10 the power of negative 3 ni? Because, okay, kita tukar milliseconds, okay, ni unit dia kecil, kepada seconds. Kecil ke besar, kita kena bahagi. Besar kecil, kita kena darab. So, bila kita bahagi, dia adalah 10 the power of 3. Bahagi dengan 1000. Okay, 1000 tu sama dengan 10 the power of 3. So, 1 over 10 power of 3, you dapat 1000 lah. So, 1000 pass per second. Okay, so ini yang ini kena bahagi. Okay, so kalau second ke millisecond, okay, you kena darab. So dia ada power lah, negative 3. Okay, contoh ni milli kan, milli 10 power of 3. So bagilah, ini 10 power of 3. So kena tahu pertukaran unit. Okay. Alright, so 1 over 10 power of negative 3, kalau you bagi, you akan dapat 1000 pulses per second. So now we calculate the bit rate. So the bit rate is equals to the pulse rate. Okay, one pulse rate is 1000 and log to L. L is the signal level. So your signal level is 2. So log 2 is 2 is 1. So 1000 times 1000 times 1 equals to 1000 bit per second. So maknanya pulse rate dia satu pulses, so bit rate dia dalam masa 1 saat dia boleh hantar 1000 bit per second. Okay? 1000 bits. Okay, dalam 1 saat dia boleh hantar 1000 bits. Okay, this is how you use the formula. Okay, of the pulses. Okay, so dalam cerita ni pula, okay, you have a signal has a 4 data levels. Okay, dalam ni dia have a 4 data levels. Okay, with the pulse rate yang sama. And we have to calculate the pulse rate and the bit rate as follows. Okay, so pulse rate kita dah tahu kalau 1 millisecond is 1000 pulses per second. So now kita kena calculate the bit rate. Okay, with the pulse rate times log 2L equals to 1000 times log 2 4. So dia kata 4 data level. So bila kata dalam 4, so dia maknanya dia boleh hantar 4 sekali dalam satu saat. Okay, so kita nak tahu berapa banyak bit per second yang dia boleh hantar. So 1000 times log 24. Log 24 is 2. So 2 times with 1000 is juga 2000 bit per second. So this is how the formula is being used. Okay, ini kena kira ya, kena tahu macam mana pengiraan. Kalau dia bagi bit rate, dia bagi pulse rate, macam mana you nak dapatkan level dia. Okay, so dia either way. Okay, you kena gunakanlah log dan index. Okay, alright. Nanti kita akan bagi contoh soalan lah. Okay. Alright, so problem ada isu di dalam digital to digital ni adalah self synchronization. Okay, so if the receiver clock is faster or slower, the bit intervals are not matched, then and the receiver might interpret the signal differently than the sender intended. So maksudnya self synchronizations. Okay, so timing is very important. Clock synchronization is very important when you transmit your data in the digital to digital. Kalaulah you punya clock tu faster or slower, so the bit intervals dia masa dia akan tak sama, maka dia akan interpret that signal in the different way. Okay, so they will be include the timing information in data that been transmitted. Contoh, bila dia hantar bit 1, okay, positive and the 0. Okay, dia hantar. Okay, ini data sender lah, device sender lah. Okay, device sender dia hantar, dia send data bits ni, okay, macam ni cantik. Okay, at the time. Tapi apabila dia lack of synchronization, so dia tak ada self synchronization, so what happen is the particular bit tu, okay, sepatutnya dia positif 1 bit per ni, okay, mungkin sebab dia slow sangat, okay, so dia sampai ataupun terlalu laju ke, so dia apa terjadi ialah dia boleh sampai 2 bit sekali, dia interpret salah, okay, bit interval tu akan bertambah dan menyebabkan dia terima positif more than 1 bit, padahal 1 bit 1 signal, tapi yang ini dia jadi 2 bit jadi 1 signal. Okay, so itu dia katakan sebagai lack of synchronization. Dia kena ada synchronization. Okay, terutamanya clock timing. Contohnya kalau kamu hantar data awak dari Malaysia pergi ke hantar ke US, so timing dia tak sama. Okay, timing dia sama. That's why bila you hantar dia akan tukar kepada universal time clock. Okay, so dia kena use the universal standard time clocks. Okay, so that there's no have a lack of synchronization. So data awak walaupun awak kat sini US masa tu tengah malam, still awak boleh dapat data walaupun perbezaan masa. Okay, alright. Sebab dia ada bit synchronization. So nanti kita akan tengok macam mana bit synchronization. Dia synchronize, okay? Dia akan synchronize the time, okay? So in digital transmission, the receiver clock is 0.1% faster than the standard clock. Okay, so how many extra bit per second that the receiver receive if the data rate is 1 kilobit per second, and how many if the data rate is 1 megabit per second. Okay, kalau kita satu 1 kilobit per second sama dengan 1000 bit that dia hantar. So bila dia terlebih, receiver clock is 0.1%. So maknanya dia ada 1 bit extra. Betul? 0.1% from the bit yang dia dapat tu. Okay. Dia dapat 1 extra bit per second. Kalau you dah ada 1 megabit per second, kamu bayangkan bila clock you faster than the sender. Jadi maka you punya bits akan lebih banyak terima. So 1000 extra bits per second. So nanti takut you punya data tu ataupun being altered lah. Okay, dah it has been changed. Okay. Alright. Itu the self okay, so issues lah. Okay, biasanya issue di dalam digital to digital transmission is the clock synchronization. Okay, ataupun the self synchronization tu. Okay, sebab masa tu sangat penting sebab the bits. Sebab nanti kalau salah, kalau sender and receiver have a different clock times, okay, ataupun lebih laju macam contoh bukti tadi, maka the bit interval tu dia akan berubah. Okay, dia akan interpret lain. Okay, so dia akan menyebabkan your punya data is not accurate, or it can be inaccurate lah. So dia tak achieve you punya effectiveness of data communication on data communication punya effectiveness. So that's why self synchronization is very important. Okay, when you do the data transmission in digital to digital transmission. So sekarang ni kita akan tengok macam mana dia encode process of encoding in digital to digital. So dia ada 3 jenis. Satu unipolar, satu polar, satu bipolar. Unipolar means once, okay, and polar or bipolar, okay. Alright. So kira unipolar encoding ni, okay, normally there's a very simple and it's a very primitive, okay. Dah tak ada dah, as absolute dah today. No one use unipolar encoding dah, okay. Alright. Dan kebanyakan devices are not support already for unipolar encoding. Okay. So apa yang dia buat ialah dalam unipolar, a bit 1 is representing by the positive voltage and the bit 0 represent by the zero voltage, or we call as a idle line. So they have two problems. Problem ialah bila you pakai direct current component dan juga synchronization. They have a problem with the synchronization. So that's why unipolar encoding will no longer use, okay, for the current punya technology. Okay, sinilah unipolar encoding. So bit 0, okay, represent no voltage, and bit 1 represent as positive voltage. Okay, one simple, very simple. Okay, problem bila dia ada direct current. So bila direct current, okay, kalau the current tu continuous, so tak mestinya the signal tu kosong. Dia mesti ada value, sama ada positif ataupun negatif. So unipolar ada lack of it, okay, and then dia masalah synchronization. Okay, so dia ada masalah sikit dalam synchronization. Okay. Alright, how about the polar encoding? Dalam polar encoding pula, dia menggunakan dua voltage. One is a positive voltage and another one is a negative voltage. So it can reduce and eliminates the direct current punya component, and synchronization problem still can happen, okay, sebab dia masih lagi dalam digital to digital transmission. So kalau unipolar dia pakai satu voltage. 1 is represent of positive voltage, 0 is a 0 lah. Okay, kalau polar dia pakai dua voltage, one is a positive and another one is negative. Okay, dia eliminate the problem of this direct current component, tetapi dia masih remain synchronization problems. Kita tengok the polar of non-return to zero L. Okey, sebenarnya dia ada dua, satu inverse, satu level. So tapi yang cover dalam syllabus awak hanyalah non-written zero level encoding. So dalam non-written zero level encoding ni, apa yang berlaku ialah your bit zero tadi dia akan represent by positive voltage and ni kena highlight sikit positive voltage, bit 1 ni represent as negative voltage. Okay, 0 as positive, bit 1 as representing as a negative. Masa ni dah ada voltan alright. So how you draw the NRZ for signals? Okay, NRZ encoding. So you have an amplitude based with the time. Okay, so you have a beats here. Okay, so ini kena buat kena drawing sebab kamu kena tahu. Okay, macam mana komponen digital to digital buat change your bits into a signal. So kalau dia pakai encoding, okay, NRZL encoding. Okay, so bit 0, dia nampak bit 0 je, dia akan jadi positive encoding. Positive voltage. And bila dia nampak bit 1, dia akan negative voltage. Okay, sepanjang ni dia akan jadi positive voltage. So untuk melukis signal dalam NRZ encoding ni, saya harap awak buat dotted line ni, okay, pemisah antara bit antara dua bit ni. You have the boundaries, okay, the boundaries by using the dotted line, okay, with the dotted line here, okay. So bila you buat dia punya sempadan boundaries here, so you can able to identify the signal terus, okay. Contohnya kalau kosong dia positif, kalau satu, okay, dia tak ada jangan buat positif negatif macam tu, dia continuous, okay, sebab dia ada voltan, okay. So you akan sebab dia sequence of bit, dia tak ada kosong stop lepas tu satu, tak ada. Okay, so you kena continue put positif, okay, lepas tu dia nak pergi negatif, dia kena turun, change to the negative, and then bila dia nak pergi ke positif balik, so dia kena naik, okay, and go to the positive voltage. Okay, so 0 remain lah the positive voltage. Okay, so bila 1, so 1 is a negative voltage, so they have to go back, okay, to turn down, okay, and change to the negative voltage. Okay, 1 to remain negative, 1 to negative, okay, and then when the 0 is positive voltage. Okay, so this is how you do the NRZ non-written zero. That's why dia kata non-written zero. They never ever touch the zero time. Okay, dia tak pernah touch the zero time. Tak ada. So dia ada sama ada positif atau negative encoding scheme. Okay,